Okay, so this is going to be my presentation about the why of a lot of the automotive technology that we've been talking about this semester, and maybe in a bit broader context, probably the why of transportation. When I first read the requirements for this assignment, this is kind of what occurred to me. I was thinking kind of deeply about transportation and the word transportation and what it meant and all of the different kind of things that it is, right? So transportation is kind of a boring word when I think about it. When I think of transportation technology, I think of people that kind of drone on about roadworks, and I'm definitely going to be talking about roadworks because that's going to be a big part of it. But just about really boring stuff. But as I started to really think about it deeper, that's where I found kind of the why of everything that we do. And it's all because of transportation. It's because people need to get places. You can see on my slide that I've got planes and boats and cars. Obviously, cars is what we're going to be going into deeply, but all of these different ways that people get around. And the why, perhaps maybe the emotional sell, the emotional connection, the deeper purpose of transportation is that because people need to get somewhere. Because people need to get to their family's house on Thanksgiving, or people need to get to the hospital when they are sick, or people need to get their Amazon Prime um, packages in 2 days. That must happen, or else, we're back in 2001. And and that is why. Maybe the emotional sell. So as I'm talking about everything else I'm going to talk about during this presentation, I want to kind of have that picture in mind. That picture of a person that either needs somebody to come to them or needs to go somewhere via different ways. One thing maybe to kind of put this into a bit more, not necessarily context, but to kind of give it a bit more gravity, is I want to think about roads, right? Roads, as you can see, we've got a Roman road. Roads have been important throughout all of human history. The Roman roads was the reason Rome dominated its from 700 AD all the way to 400, or 700 BC all the way to 400 AD. It's all because of roads and transportation that they did all of that. It's also apparently because of roads that the space shuttle is the size that it is, or at least that's what a plaque at the NASA museum in Orlando told me. And then lastly, I kind of want to talk about the interstate system, which is kind of cool because I recently read a article about how the United States interstate system is the largest and most expensive human project ever done in the history of humanity. The human beings have never engineered or built anything more expensive or larger than the United States interstate system. And it is a great system. I have lived in other countries where it costs $40. In Japan, it costs $40 to go 100 miles on their interstate equivalent in like express lane fees. And it is wonderful to be able to get on a road for free here, get on the interstate for free here, and just go somewhere. When I moved from Arizona to Florida, it was literally 4 turns. A couple left turns to get onto the I-10 and a couple left turns to get off of the I-10. So our interstate system is insane. And a transportation project, a transportation technology project. So next I kind of want to give maybe a bit more detail as to kind of maybe about when I talk about the why of certain things, or well, I should probably go into what the structure of the rest of this presentation is going to be. I'm going to introduce a bunch of various technologies in the automotive industry and connect it to why. Why to both the greater why of transportation technology, but also these little bit more focused reasons of why we do things, why these technologies exist. So I've kind of, in my opinion, and from doing this class, I think I've boiled down to 5 reasons why a given automotive technology is developed. And that is either to help the environment, or at least to comply to environmental regulation, to be safe, to improve safety, to improve general thrill and fun, because why else would race cars exist, right? To decrease cost or to make profit, and to improve convenience, because there's certainly, you can certainly sell people on convenience, so that's something that people want. So first, let's briefly go over a lot of the things that we talked about in this class. I want to just connect these really quickly to why, and then move on to things that we didn't really talk about in class, just for fun to talk about some new things. Obviously, one of the first things we talked about was diesel exhaust treatment. That one's pretty clear. It's the environment, right? Diesels are not very good when it comes to air pollution, so we need diesel exhaust treatment to fix it. And people like the environment, people like going out in nature, and they want to protect it. So why do we have diesel exhaust treatment? Because environmental safety. E85 and other biofuels, same thing, but you can also connect that to cost. It can make things cheaper, it can make things more important, and then you can also connect that to thrill, because an E85 tuned vehicle can go a lot faster. And next we have electric propulsion. Again, the environment, but also convenience and cost, because it's cheaper and it can be pretty convenient just to kind of plug in your car at the end of the day, just like you plug in your phone. And thrill, because Teslas are fast, plain and simple, right? And next we have CAN bus and other comm systems on vehicles. These are for a lot of different things. I think you can say for convenience, it really helps out technicians. For cost, it significantly decreases the cost of repairing and maintaining your vehicle, as it works really well to keep things going. Environment, it allows your engine and the rest of your vehicle to communicate with itself and to run more harmoniously as it's burning through its fuel and things like that. And then the last thing that we kind of talked about was telemetrics. This is obviously separate from CAN bus, as it is a little bit more about the infotainment and the driver's connection to the vehicle, but also the vehicle to other vehicles and other communication systems like that. I think telemetrics is really cool, and something that is going to be deepened a lot in the coming years for vehicles. And then again, why the environment, it can actually, why is the environment? Now that I say that, why would that be? I think I'd have to really stretch to connect that. But convenience, traffic, that's a big one, right? Traffic, telemetrics could solve so much with traffic, especially with autonomous vehicles. If all vehicles are communicating with each other and moving, it just becomes a beehive basically on the roads, right? Where everybody is perfectly communicating and moving in this really, really fluid and dynamic system, because all of these cars are interconnected with each other. And that obviously decreases cost too, because time is money. So all of those good reasons. Let's move on to some new stuff. I think definitely we are in the last era of the the combustion engine. It's dying. I think we will definitely all be moving to electric at some point. However, I do really like the gas engine, and I think there is really, really interesting technology on the forefront and kind of coming to improve its performance, but also its efficiency and so on and so forth. So here are some really cool technologies that I want to talk about real quick. It's Toyota's dynamic force engine and Mazda's spark controlled compression ignition engine. So the dynamic force engine is really cool because it can achieve 40 I believe it's 40 to 42% thermal efficiency, which is insane. No mass market engine has been able to achieve that up to this point. It's generally just an accepted rule that engines are only about 20% thermally efficient, but that's not true anymore. Now that one of the most marketed cars in the world, the Toyota Corolla, is fitted with an engine that has 40% thermal efficiency. And one of the ways that it does that, which is really cool, is basically by just controlling the flame front in the cylinder and the flame propagation. So the flame propagation in the cylinder, the flame can explode much faster than in a traditional engine, which allows for less energy being lost to heat from the burn, and from that if a slow burn, it just has more time for heat to kind of escape the cylinder, but also more energy to be put into the piston for downward force and to drive the vehicle. Really, really interesting, really cool stuff. They also do some things that they derive from F1, where they controlled the spark front. There's gas. The spark isn't directly in the cylinder itself. Instead, it allows some of the compressed air in the cylinder to enter a chamber and get a better spark from that. So really cool stuff with Toyota's Dynamic Force engine. And then the big one is Mazda's spark controlled compression ignition. One of the reasons I really like Mazda is because I feel like they are one of the world's great engine builders, at least engine innovators, and they're definitely doing that with their next level of engine. Kind of a funny thing, one of the things that I learned, just a funny story, one of the things that I learned while I was working as an intern for Toyota is that Toyota stole Mazda's current Skyactiv technology. What they did, if you see the Scion IA, which is sold in the American market, is really the Mazda 2, and they bought the rights to manufacture that car, not because the Scion IA is a huge seller in America, but because that would give them access to Mazda's Skyactiv technology. However, Mazda, with their new engine, says screw you to that and already had something better in the works, and that is their spark-controlled compression ignition, which is exactly what it sounds. It's the best of both worlds, of diesel engines and gasoline engines, where they can achieve super high efficiency of diesel engines from compression ignition without the emissions, because they're using gasoline, which burns much cleaner and much more completely than diesel gas does. How they do this has a lot to do with the cylinder head design, but also with the timing of the spark and the control of the spark, because they still use a spark plug, but only when the engine is cold or the engine is in idle. As it speeds up, they can gain more control of the compression and the heat in the cylinders and things like that, which allows them to keep the engine from having pre-detonation or any problems like that. Next, let's talk about anti-lag. Anti-lag is fun. One of my favorite things to watch on YouTube are rally video compilations. However, I'm not going to talk about race cars. I'm going to talk about production cars. There is a lot of anti-lag currently, of factory design anti-lag systems on the market today. Porsche, in every single one of their models, especially now that the next 911 is going to be turbocharged from the bottom tier up, every single one of their models uses a soft form of anti-lag. Also, a lot of production cars currently are cheaper ones, like the Hyundai Veloster is going to start using it, and the reason is because they're just putting turbochargers on everything for the sake of efficiency. So to keep throttle response smoother and things like that, these manufacturers are using anti-lag systems, and the most common one that they use is really just programming. It's just engine programming. And what they do is they open the throttle plate on idle, or not on idle, but when you lift off the gas, and when a throttle would normally be shut, it's actually all the way open, and the gas injector, the fuel injectors are turned off. So that way you're just pumping air, and you're pumping air into the exhaust manifold, which is spooling the turbo and keeping the turbo up there. So really cool stuff with using anti-lag on a production vehicle. Again, why do we do these things? Thrill, efficiency, convenience, all sorts of good stuff. Next, let's talk about some hybrid systems. Really, 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 really cool stuff going on with Formula One, and really extracting just as much power and thermal efficiency out of their hybrid engines as possible with the MGU-H, MGU-K, MGU-E, which is just all of these extra power units that they tack on to their little tiny 1.6 liter engines to get more power out of them. And that is going to trickle down to production cars. Already we see supercars being performance-based hybrids, but Audi is going to start using, and a kind of a trend with Audi, well, with lots of premium tier automakers, is to use mild hybrids to control other systems in the vehicle. So lots of fun technology going on with hybrids that I'm not going to talk about in depth. And then, as I was saying just now, that Audi uses a mild hybrid system for some of their things, I want to talk about anti-roll bars and active anti-roll bars and kind of their use. And I think they're actually going to start being used more. And one of the reasons I feel this way is because the death of the car, right? How most of the US market is moving towards raised crossovers and SUVs. Well, I think one of the ways that we're going to do or continue to market cars for people is to make them better driving, and raised SUVs are definitely going to need active anti-roll to keep them driving well. They've already made huge improvements, but they can do better, right, than a car. And so one of the ways that they do this is through active anti-roll on Audi, is where there's a motor on the roll bar itself, and just like a torsion bar suspension from American cars of a long time ago, it just torques down on that anti-roll bar, which gives it a lot more spring and can increase the stiffness or decrease the stiffness depending on how it spins it. Audi uses their 48-volt mild hybrid system to do that, because that motor needs to be a lot stronger. Other anti-roll systems, which are too expensive for plebeian cars, would be what McLaren uses, which isn't a roll bar at all, but actually pneumatic tubes and a diaphragm where that fluid is active. So when one wheel pushes up, that fluid pushes down the other wheel, and so on. And then that diaphragm, as it, just like a monotube or dual tube shock would, as they control that, as that diaphragm either gets larger or smaller, it increases the pressure on that fluid, which in turn stiffens or loosens the anti-roll system. And that is it. That's a lot of really great technologies that we have in our cars. And again, just, why do we do it? We do it because either we want to make things cheaper and more convenient, or we need to protect ourselves or the environment, or because we want to, because it'll make a car better. These are just kind of a shotgun of different technologies in the automotive world, but I kind of hope by sharing them and by showing just how cool they are and all their capabilities, I can kind of at least convince you or anybody else listening to this presentation why we transport, why we automotive technology, why do any of it. And thank you for listening.